Hello everyone, this video is for the DevOps milestone 3 in which we have to work on the deployment of our application. So we have certain tasks. So first task is to create our deployment environment in the production environment. So we are using AWS as the hosting environment and we are using configuration management tool Ansible to interact to install the software over our AWS instances and all. So what I'll do is I'll explain the first two tasks, then I'll execute them because it takes some time to execute each task to create the instance and then followed by installing all the required packages over that instance. So for first task we have this task1.yml. This is my Ansible playbook for creating the Ec2 instance. We are using this Ec2 module to create our Linux image on the US East 1 zone, and then we are adding it to the host, and we are waiting for the SSH port to be available, because after that once that available we are then installing Maven and default JDK on that instance. So we need these two packages to run our Maven application, um, because our joda-time application is built in Maven. And followed by that, our second is the to transfer our whatever the code is on my local machine to the AWS instance. To transfer that code, I have this shell script file, which first it gets the IP address of the instance that just created using this JavaScript file. Followed by we are compressing into the tgz file our joda-time source code, and then we are using the scp command to copy over the this remote instance. Followed by we are also copying this redis stable version because we need the redis server to be also run on that aws instance, so we are also copying it, and I'm also copying this aws task.sh. What this shell script does, it just basically untar those zip files, and it starts the redis server. Followed by it starts the Maven site on the port 9000 on our AWS instance. So uh, so continuing from our milestone 2, we have this pre-commit and post-commit file wherein we are checking different things. And in post-commit, whenever the build is successful, I am just basically calling this playbook followed by m3.sh, that shell script, and then I am using the Ansible to call aws task.sh, which I just copied over uh, to the instance. So these three things would run whenever my commit is successful. So this task1.yml will make sure that only one instance is created. If the instance is already there, it will not execute the task. So let's run these two tasks. So I do git status. I have some changes. I do git add git commit task 1 and 2 demo, and I commit this. As you can see, the pre-commit hook has been running, which checks for different things like hardcore security keys and any key files, checking for the comment ratio and give up the output. Uh, Followed by the post commit. So as you can see, the post commit has been started. It will post commit will push a build to the Jenkins, and Jenkins will run the all these statuses, all the find bugs and test result code coverages on all these plugins to make sure that the build is successful or not. As you can see, the build number 70 has been started now, and once the previous build was 69, once that build is successful, then our playbook will run in the post commit, followed by the m3.sh and followed by the aws task on the remote instance. So since this will take some time, I'll pause this video for now. As you can see, the build has been successful, followed by task1.yml playbook has been running. So it has created the instance with the ID 71B127CCF. Now it is waiting for the SSH port to be available. Once that SSH port is available, it will install the Maven and JDK package on that instance. So we can see the newly created instance with that ID. Yeah, there's the one. um, I can just copy its address so that I can show once it is up and running on the 9000 port. You can see in Jenkins as well, build number 70 has been successful. So it will again take some time. Meanwhile, I can explain the other tasks. Like the third task is to use the feature flag. So how we have implemented the feature flag is like we are running this redis server on the AWS instance, and we have added a code in our Java package, which is in source. This is the new code that has been added. What is does is like um, this connect to redis is a redis client. It will just create the redis client. So for redis we have this maven package called lattice, and we have incorporated it in the pom.xml, and we have it in the maven dependencies. So we are importing it as a package and using that to create a redis client. So according to the singleton pattern, it will just create the first one instance, and once the instance is client is created, so we have this flag that set minutes day flag. So what it will do is it will just put the flag in the redis server, and when we print the date, it will print the correct date if the flag is on, and if the flag is false, it will just return the null. So I have written this both these statements so that we can show the once the redis flag is on or off, we can have the feature turned on or off in the production based on this flag. So I'll show the execution once our instance creation is done. So instance creation has been done, SSH has been available. Now it is waiting for the installation of the Maven package as well as JDK package, because we need this to run the Maven commands like Maven site run on particular port. So what I'll do is I'll pause this video again. So as you can see, it has installed the Maven and JDK, followed by it has copied this uh, zip files, joda-time as well as redis server file uh, over the server over the instance. So what it is now doing is it is basically running this AWS task.sh over the instance, in that it will just untar it, it will run the redis server, followed by it will run the site. um, as I can see on the created instance, I just added one alarm that it is for the third task to have it is for the fourth task to have some monitoring. So in the fourth task we are monitoring, the first is just we are using this cloudwatch provided by Amazon, and I added one alarm that whenever the CPU utilization becomes more than just say 1%, it just goes gives me the alarm, and it just sends me an email. So I just got an email with that high CPU utilization as a subject. So similarly, I can add another alarm, like let's say I want to write the disk write operations, uh, disk writes on that on this instance to be if it is greater than let's say 4, and in any instance, and I create this alarm, uh, I would get the whenever the disk size becomes more than that, I would just get the alarm. So currently the average disk size is 0, that's why I'm not getting any email, but whenever the disk size disk write bytes exceeds my limit what I have provided, it will definitely exceed. So let's say if I do instead of average, I do data sample, because the data sample disk write is 5, and I save these changes, I would definitely get an email whenever this whenever this monitoring would be done. So how cloudwatch works is like it monitors after every 5 minutes. So as you can see, the alarm has been triggered. I must have got the email now. So I high disk writes. I just got an email about high disk writes. So that's how we have implemented our fourth task of this milestone. The fifth task is to ability to perform a canary release using the proxy or load balancing server. As you can see on the server, this site would be running now. uh, I apologize, I had to pause the video, and because the Maven was not installed, I had written in task YML that I was installing the Maven first, for then Java. So because of that, Maven was not installed, so I had to install it manually by SSHing into the server. And now we must be having our site on. Yeah, so this is the site which is on the AWS instance on port 9000. As you can see, so that goes our first second task. So I'll be explaining third task later on. I explained the fourth task to have the two metrics, one for the high disk write and one for the high CPU utilization. So I'll explain the fifth task first, or I can go ahead with the third task. For the redis, let's say I do SSH into that machine. Um, so the command is, I have to see. So it is similar to SCP, but with just the name of the machine, I have to write it into the command. What I can do is I can explain the fifth task first, because we are on the flow. So in fifth task is like to have the canary release. So what we are doing is we are having the new instance being created for some new feature. So let's say I make some changes in the code, like I update the site, like I update the site source code. Like in on the site, if you see, I see that in the features I see something, so instead of features I do new features, something like that. And new features 1 2 3, I do that, I update that, and I do commit. So in, okay, yeah, in git status I can see this status been updated. And if I add this, so now what I have to do is I have to change the our post commit file to have the task 5 ansible playbook running, because in task 5 ansible playbook what it is doing is it is creating the it is making sure that two instances are created. So it is creating the additional instance, and uh, which is our canary instance, and having our new code, new feature being pushed out to that canary instance. So what we will have is on the port 9000 we will have two instances. So one instance will show the old side and one instance will show the new side, that is the product with the new feature, as you can make an analogy with that. So I'll update just the post commit file, and I'll run the same thing again. I'll so it will again run the post commit and pre commit, peak pre commit followed by post commit, wherein it will do all the checking and it will create a build and all the stuff. So now we can go to the third task. In the third task what we are doing is, as I said, we have this flag in our feature flag file. So feature flag file was in source, yeah, in feature flags file. So if I just go to the go to my host machine, I SSH into it with my key and user. mm, yeah, it takes some time sometimes. Yeah, I can see my folders. If I go into the folder which I want, so what we have is we have this jar file being stored in this class. So I'll just run this jar file with the class as package name is redis dot feature flag. Yeah, so if I run this, I'll get this two output, as you can see. So first output gives the correct datetime because the flag was set as true before, and then I made the flag false, and thus that's why it returns null. So on the server side we have this Redis server running, and we are switching out the flags based on the value in the Redis server. So that goes our fourth task. For the fifth task, I guess it would be still running. Yeah, so it is just commit has been pushed. Now it will be creating a new instance. um, I'm sure it will take some time. So once the new instance is created, I have this load balancer created already. I will add these two instances into this load balancer, and for the load balancer I have written the uh, health check condition as the on your instances check on the forwarding on the port 9000 as the index.html, and if it is not giving anything problem, then the health is good. So once the two instances are created, I'll just add them. I can add the first instance which is running. Yeah, the second instance has started, but it is not yet available completely. So I'll just add the first instance, which is 71b12. um, so we have this first instance running. So if I uh, go to the site of load balancer, I should be able to see the same side which I am seeing on the joda-time. I guess it will take some time to add the instance in the elastic load balancer and to have it running, but it does work. So yeah, on the instances you see the another instance has been created. It is still getting initialized. It is still waiting for the SSH to be available. So once the SSH is available, it will in our task 5 it will install the Java and then Maven, and it will run the Redis server and followed by the site. So what we will have is on our load balancer side, we would once see the old site which is the with the features, and we would sometimes see the more new features as an updated UI. um, is still running, so I'll pause this video for a bit to get that thing running. So I guess the site is up and running now. It took some significant time. So if we go to this new instance on the port 9000, I should be able to see the updated code. Yeah, I see this new feature 123 I just updated. So let's say this is the new feature in our canary release. This is the canary release instance, and this is our old instance. If I refresh it, I still get the old code, and this is our new release instance. And this is our load balancer instance, which is like working as a facade between these two, and it distributes the request between these two instances based on their availability. So uh, if I hit it multiple time, at least one time. I need to add this instance to the load balancer first. Yeah, so I add this instance, let's say, to the load balancer now. It will take some time to have this instance up and running, because instance health threshold health check is like it should be healthy for at least 2 times. So it will ping 2 times to this website, and once it is healthy, then only it will add. So uh, we will wait for a bit to have this instance being added. So yeah, as I think it is being in service now. Let's see. if I hit it multiple times, I should be able to get the new feature. Yeah, so you see, sometimes I get this new feature, sometimes I would get the old side as a feature. So based on the uh, how available the two instances are, EC2 load balancer diverts the traffic between these two instances. So that's our canary release, and the traffic is being distributed between these two events. So let's say I can put some rule uh, in the load balancer as well, like if any of the instance go down, let's say uh, healthy host, if it is less than 2, not some. uh, yeah, if I get the healthy host at less than 2, that is if any of the healthy host goes down, then I should be able to get messages so similar to alarms we created in the for the instance one. We have this alarm for our load balancer as well. So let's say if I make some changes, I do some if I do some I put the canary site as down, like if I stop the canary site, let's say now I won't be able to see the canary site on this instance. So after some time, when the health check will do, yeah, it has triggered the alarm. You can see, and I should have got the email. Yeah, but I'll get an email like saying that the EC2 uh, healthy healthy instances has been less than 2. So okay, I still haven't got the email. Alright, so this is still the old email, ICP utilization. Yeah, as you can see, high healthy cost. I got an notification because I dropped down the side of the um, canary instance. So now the traffic is only being diverted to this instance, that is the old production instance that is being running. So that's how we have achieved our fifth task. um, so I think that pretty much covers everything. Thank you so much for listening.